under the tree, if you stand, you might have seen the focus will be come to you through
Yes,
those
ma'am.
leaves in the, it won't come in a straight manner. It will come in this way, right? By scattering,
Yes,
isn't it?
ma'am.
Yeah. So this scattering phenomenon by the particles present into the atmosphere of a light is called as a Tyndall effect. Very simple factor about it. Now see, suppose you have a small hole to the window. This is your window, right? And there would be very small hole at the corner or somewhere, or slit. A small slit would be there. If you observe at your home, this hole's light would be fallen on the ground, and that would be quite large enough, isn't it? Yeah.
Yes, ma'am.
Large light would be fall. Those this dot or this hole would be really very small. Why this happened? This is also happened due to scattering of light.
Ma'am,
Correct?
did we discuss colloidal solution?
Sorry.
Did we discuss colloidal solution?
Yes, yes, we are going to discuss about the colloidal solution, and even we are going to discuss about the suspension. But then before that, you should understand this Tyndall effect. If you understand Tyndall effect, there is nothing to means like teach much in that, because these all things are comparative, like particle size, stability, filterability. These are comparative facts, right? But then Tyndall effect is the thing which is not in this way. It's quite different, and it's completely depending upon that particular solution. Now, what I said about the solution earlier, solution particle size is what? 1 nanometer, correct? This is what?
1 nanometer. Particle
Particle
size.
size. Okay. Now, this particle size is very, very small, which we are not able to see with our eyes, right? And as we are not able to see with our eyes, these are really very small. So light beam cannot be scattered by these small particles. And hence your solution does not show the Tyndall effect. So what is the essential condition to show the Tyndall effect?
The particle size.
Particle size.
Particle size.
And this particle size should be lies in between what?
Ma'am, 1
In
nanometer.
between 1 nanometer to 10 nanometer or more than that. Okay. In short, we can say if size of particle is more than 1 nanometer or above 10 nanometer, it will be show your Tyndall effect. Less than 1 nanometer in the solution, it does not show Tyndall effect.
Yes,
Clear?
ma'am. Yes, ma'am.
Understanding?
Yes, ma'am.
If in your solution, if there would be the particles scattered throughout its bulk, and if you pass a beam of light with the help of torch, so this torch light will be go and collide with this particle and scattered its path. This path will be visible when the particle size is above 1 nanometer.
Yes, ma'am.
And then this phenomenon or the process is called as what? Tyndall effect.
Tyndall effect.
How are you going to define it?
Ma'am, the scattering of light.
Shall I, or you will you
Ma'am, it would be like the scattering of light
Between
after
1 nanometer and 10 nanometers or more than that.
that is your understanding. So you can't define in
ma'am,
that
it shows, ma'am,
process
it is
or
happening
phenomenon. Yes. What is the
when the
Tyndall
light
effect?
when the light passes through the particles and gets scattered.
Yes. So this is the process or phenomenon in which light beam or light path, when travel through the medium, it gets scattered by colliding with the particles present in the path. Okay. This is called as what? Tyndall effect. It is happened in the range of 1 nanometer to 100 nanometer. Less than 1 nanometer particle size does not show Tyndall effect. Clear? So one more
Yes,
question
Ma'am,
might arise in your mind, like
ma'am,
why
once
this
again,
whole,
can you tell the definition?
yeah, sure. Why this whole get the scattered, or from the slit also you will get the such a big light in your house. So these all things are happen due to scattering of light. So you may feel like that, ma'am, how it is possible, how scattering of light will be happen in this case? It happens due to the dust particle present into the environment. right? Though dust particles are small, which we are not able to see, but then they are larger than that of your 1 nanometer particle. In that light, if you see clearly, you might have seen the particles randomly moving in that particular light. Isn't it? Have you ever observed?
Yes, ma'am.
If you observe that light clearly, you may see the particles present in that path. And those particles are responsible to scatter the beam of light and show the Tyndall effect. Fine. So what is the Tyndall effect? It is the process or
Ma'am,
phenomenon
when the light
of
beam
copper.
travels through an area and gets scattered between 1 nanometer to 10 nanometer, it is called Tyndall effect.
Yes. Or else you can say the process or the phenomenon in which scattering of light takes place by the particle present into the path of light. It's called as Tyndall effect. That's it. Okay. Shall I define it again? If you want to write, let me know.
Yes, ma'am.
What is Tyndall effect?
Ma'am, the process through which the light beam travels through the area getting scattered by the part of light.
Yes.
Path of light.
Particles of the light. By the
Yes, ma'am.
particles present into the path of light. Okay. The Tyndall effect is what? Process or phenomenon. Okay. Which scattered the beam of light by the particle present in the path of light. Or else you can say in the medium. Path of light is nothing but what? Medium. Is called Tyndall effect. And essential condition for it. First
Ma'am,
one,
1 nanometer particle size.
particle size should be
1 nanometer to 10 nanometer.
from 1 nanometer to
10
above
nanometer.
100 nanometer, you can say, or 1 nanometer and more than that. Okay, fine. Okay, clear?
Yes, ma'am.
Anybody have any doubt about it?
No, ma'am.
Okay, I hope all of you understand that now. Okay, the thing which I actually wanted to explain you, the next, that would be the solution and solution examples. Okay,
Ma'am,
solution
solution is a
already we have
solvent and
learned.
solute.
Yeah, already we have learned what solute plus solvent is what?
Solution.
Sorry, solute plus solvent is solution. In that, what I said, solute would be in
Ma'am,
less quantity and solvent is in large
more.
quantity. Yeah, correct?
Yes, ma'am.
Yeah, and later you will get the solution. If solute quantity is more, then your solution become concentrated. If solute quantity is less, then your solution become dilute solution. Correct?
Correct, ma'am.
Yeah. Now, about the solution, few examples I would like to explain you, because few of you had a question in your mind, like only solid and liquid will form a solution of what? So it's not like that. Most of the time, your solute can be solid, your solute can be liquid, your solute can be gases. Okay, any phase of the state or any state of the state. Any state of the matter. Sorry. The state of matter you have learned in the previous chapter, I guess, right? Yeah. Solid, liquid, gases and its characteristics. You have
Yes,
learned
ma'am.
now. Fine. So the first example which I would like to tell you, that is the solution of sugar in a water. If you see the sugar in a water, this is the solution of solid and liquid. Correct?
Yes, ma'am.
Yeah. And the next solution would be iodine in alcohol.
Ma'am, liquid plus liquid, right?
Iodine won't be liquid. A solution of iodine, acha. A solution of iodine, not only iodine balls, because iodine can be in solid state as well.
Yes, ma'am.
Okay. If you take a solution of, yeah, if solution is in liquid state, it will be added to the alcohol. What you'll get? Liquid into liquid.
Yes, ma'am.
Okay. Then the next one is what? Aerated drinks. Have you heard?
Yes, ma'am.
Coca-Cola, Pepsi. Yeah.
Yes,
In that,
ma'am.
what carbon dioxide you add into the liquid, isn't it?
Yes, ma'am.
Yes.
Yeah. So aerated drinks, if you see, in that gas into liquid. Correct? Fine.
Yes, ma'am.
Yeah. And another one is what? A mixture of gas or the air, if you write. Air is a mixture of what?
Gas.
There would be oxygen,
Yes,
then there
ma'am.
would be nitrogen, then there would be dust particles, right?
Yes,
Right?
ma'am.
Yeah. Even there would be what? Apart from that dust particle, any other thing? Smoke.
Vapor.
Yeah. Carbon particles. Right? Carbon dioxide and other gases. So it is a mixture of several gases. So this is also a solution in which gas is added into gas. So I hope your confusion has been completely gone. Like you had a question about it, what? Whether solution is made up of only solid or liquid. So it's not like that. Solution won't be made up of only solid and liquid. It can be solid liquid, it can be liquid liquid, it can be gas liquid, or it can be gas gas. Even moreover, it can be solid solid as well. So what would be this solution? Solid solid solution. It's nothing but what? Alloy.
Alloy.
Okay. Just give me a while. Just give me a while. Hold on.
Ma'am, we can take brass.
Am I audible?
Yeah, ma'am.
Yes, ma'am.
Yeah, sorry. I'm extremely sorry. Little disturbance was there. So understood about it? Alloy? Any
Yes, ma'am.
example of alloy can you give me?
Brass.
Okay, brass. Okay. Then bronze. Then stainless steel. Right? Yeah?
Yes, ma'am.
Yeah. And even the nichrome.
Yes,
Nichrome
ma'am.
wire is also there. That is also nothing but what? Alloy. You might have heard it in your physics. Isn't it?
Yes, ma'am.
Nichrome wire. Yeah. So it is made up of what? Nickel, chromium, magnesium. Yes? Yes or no? And even iron also would be present in that. So
Ma'am,
mixture
magnets.
of in this solid mixed with solid. Okay, clear?
Yes, ma'am.
Fine. So
Yes.
your doubt is gone. Means solution can be anything in which one solute and another solvent would mix with each other in any state of matter. That can be solid, solid, that can be solid, liquid, that can be liquid, liquid, that can be liquid, gas, right? That can be gas, gas. Clear?
Clear.
Fine. Shall I erase it? Have you wrote?
Yes, ma'am.
Fine. Shall I erase it? Now the next thing which we are going to see, that would be the next is what we are going to learn about concentration of solution. That part we are going to learn. This is quite new for you. You might have not learned it before. Okay. Oh, I'm sorry. Now in this concentration of solution, what I actually wanted to explain you, what do you mean by the concentration first? Okay, concentration of solution means what? Already we have seen the solution would be made up by what? Adding solute and
Solvent.
solvent, correct?
Yes,
Isn't
ma'am.
it? So amount of solute present in the given solvent at that particular temperature is called as concentration of that solution. Understanding? What is the definition for concentration of solution? They have given you certain activities. Yeah. They have given you what? A certain activities. But then what I feel like instead of that, you should be understand about the solute and solvent in detail. If you
Ma'am,
are,
could you repeat the definition of concentration?
sorry, what you asked me?
Ma'am, can you repeat the definition of concentration?
Yeah, sure. Concentration is what? The amount of solute present into the given solvent at that particular temperature
Okay.
is called as what? It's called as
Concentration.
concentration of solution. It's called as what?
Concentration
It's not
solution.
solution. It should be solution. Okay. I have written here solvent, but that would be the solution.
Ma'am, so the amount of solute present in solvent at that temperature is called concentration solution.
Yes. Understanding how much amount of solute is present in given solution at that particular temperature is called as what? Concentration of that particular solution. Clear? Yes or no?
Yes, ma'am.
Fine. That's really very simple thing. But then point is what? Whenever it comes to the numerical, many of the children will get confused. It should not be happen, isn't it? Fine.
Yes.
Just a minute. Shall I erase it?
Yes, ma'am.
Okay. So concentration of solution, on the basis of that, your solution is classified in the 3 different groups. Okay, that we are going to see. Already I have explained you the concentrated solution. And dilute solution, right? I have explained you or not?
Yes,
That's only I
Yes,
said. It's depending upon the amount of solvent present in that. If the quantity of solute is more, solute plus solvent is there here. And here also solute plus solvent.
Ma'am, you haven't told us about the dilute solution, right?
Yes. Now, so if solute is more, quantity of solute is more and quantity of solvent is less as compared to that time, such a solution is called as what? Concentrated solution. Whenever solute quantity is less and the solvent quantity is more, that time it is called as what? Diluted solution. Now, concentrated solution can be converted into dilute solution by addition of water or by addition of solvent. Okay. Understanding, when you add a solvent in your concentrated solution, it will be turned into dilute solution. Clear? Apart from that, the solution is further classified into 3 different groups. Solution is further classified into 3 different groups. That would be saturated solution, unsaturated solution, and supersaturated solution. Saturated solution, then the unsaturated solution, and supersaturated solution. Correct? Yes?
Yes, ma'am.
Yeah. Now, what do you mean by saturated solution? You have heard this word before? Hmm? Have you heard this word before? Yes or no? Saturated, unsaturated. Okay, I'll give you the example. Now see, suppose here is a beaker. Okay. In this, suppose 50 ml of water is present. And I'm going to add the pinch of sugar in that. Okay. Then I'll stir it. It will get dissolved, right? Again, I will add some more sugar. Again, I'll try to dissolve it. Again, I will add some more sugar. I'll try to dissolve it. At certain time, means after certain period of time, what happened? It will dissolve all the sugar, how much it is capable of. Because in the previous chapter, you have learned the like characteristics of the particles, isn't it? Yeah.
Yeah, ma'am.
Yeah. What you have learned in that? What you have learned in that first, second property of the particle is nothing but what? Matter, particles of matter has a space between them.
Yes, ma'am.
Yes, no?
Yes,
You
ma'am.
might have learned that. So as matter of particles of matter has a space between them, they're capable to dissolving another substance inside it. Because of that only, your sugar would be occupy the vacant space in between water and get dissolved. Correct? Yes or no?
Yes, ma'am.
Yeah. So if that space would be completely filled by the sugar molecules, sugar is completely get dissolved, that complete space is occupied by the sugar. So what happened? Sugar will get dissolved further? No, sugar will not dissolve. It will settle at the bottom, isn't it?
Yes, ma'am.
Yes or no? It happens or not?
Yes.
If you don't, like if you don't have this idea, like you have not never analyzed this
Yes, ma'am.
experienced it. So do one thing, take some water in a cup, okay, and continually add sugar in that. At certain time, it will stop dissolving in that and it will settle at the bottom. It happens by yourself as well. You can do it. Okay, you can do it at your like by yourself at your home. So such a simple experiment it is. Correct? Yes or no? So when you see that, what you come to know, this solution is a capable of dissolving certain amount of the solute. But if you add beyond solute in that, it will settle at the bottom. It will not capable to dissolve furthermore solute in that. So such a solution is called as what? Saturated solution. What would be the proper definition for it? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be saturated solution. Or else, in another word, we can define it in a manner when no more solute can be dissolved in a solution at a given temperature. When no more solute can be dissolved in a given solution at that temperature or at given temperature, it is called as saturated solution.
Ma'am,
So,
where?
yeah,
Ma'am, where?
at that particular given temperature.
Okay, ma'am.
Because if temperature is increases, solubility also increases.
Ma'am, could you
Understanding?
once more repeat? I didn't understand the definition.
Yeah, sure. I will explain once again. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving inside it. It's said to be saturated solution. Or another definition, when no more solute is dissolved in a given solution at that particular given temperature is called as saturated solution. I think second definition is quite easy for you.
Yes, ma'am.
So what would be the definition for that?
Ma'am, where no more solute is dissolved.
When
no more solute is dissolved.
no more solute is dissolved
At that point of temperature
in solution
in solution, at that
at
time,
given temperature
yes, ma'am.
is called as saturated
It is solution.
solution.
Ma'am,
Why
actually it's no
temperature
more
is very
solute.
important?
Ma'am,
Why temperature is very important term? Because if temperature is increases, solubility of solute is also increases. Understanding?
Yes, ma'am.
So this is very important fact. So you always have to use this word at given temperature. If you forget about it, your definition would be wrong. Clear?
Clear, ma'am.
And when solute get dissolved into the given solution at that particular temperature, that is nothing but what? Unsaturated solution. Understanding? In short, dilute solutions are nothing but what? Your unsaturated solution. Clear?
Yes, ma'am.
Good to know. What do you mean by unsaturated solution? When solute get dissolved in the solution at given temperature, then it is called as what? Unsaturated solution. Now, what about the supersaturated solution?
Ma'am, when solute cannot dissolve in solution at that given temperature, it's unsaturated, right?
Yes. So saturated solution means what? The amount of solute, it exactly equal to the capacity of that solution to be get dissolved. But then if it is more than the saturated solution, then it is called as supersaturated solution. Understanding? If the quantity of solute is more than the saturated solution, saturation level, then it is called as supersaturated solution at that particular temperature. Understanding? So thing is what? Whether it get dissolved or not. First of all, you have to see solute dissolve in a solvent or not. When solute dissolve into solvent, that time it will be saturated solution. When solute get dissolved into the solvent, that time it is unsaturated solution. When it won't get dissolved further, it get dissolved up to its capacity, then it is saturated solution. And when it amount of the solute present into the solution is beyond its capacity or beyond its saturation level, that time it is supersaturated solution. Clear?
Yes, ma'am.
Okay, fine. Just give me a minute. Let me check whether I have a video regarding that. If I have the video, I can show you. Or else I'll plan it for tomorrow. I don't want to waste your time currently. Fine. So today we have learned about what?
Ma'am, concentration solution.
Dilute solution, concentrated solution, right? After that, what we have learned?
Ma'am, Tyndall effect.
Tyndall effect we have learned. Then we have
Ma'am,
learned about the
again,
saturated,
dilute,
unsaturated, and supersaturated solution.
supersaturation.
Even we have learned about the concentration of solution, right?
Yes, ma'am. Ma'am,
Yeah.
what is the diluted of solution? You didn't explain that, right?
Yes, yes. I'm just going to recapitulate the things. And once I have recapitulate, I'm going to give you the formulae for the calculation of concentration of solution. Okay,
Yes, ma'am.
fine. Okay. See the first one, the point which we have learned today, that was the Tyndall effect, right?
Yes, ma'am.
Yes.
What is the Tyndall effect? It is the
Ma'am,
process of scattering
when
of
the
the
light beam travels through the area, by the particles of the path of light is called Tyndall effect.
scattering of the light by the particles present into the.
Yes, ma'am. Ma'am, and its particle size should be 1 nanometer to
And
10
above.
nanometer or more than that.
Yes. Okay, scattering of the light by the particles present into the medium or path of the light. Okay. What is the important term in this? What is the important term? Particle size.
Size.
Yeah. Particle size from what to what? It should be.
1 nanometer to 10 nanometer or more than that.
Yeah, more than 1 nanometer. Whatever it would be, it can scatter the beam of light. Fine.
Yes, ma'am.
Now, second point which we have learned, that is what? Solution.
Is
Right?
solute plus solvent.
Yeah. So solution is nothing but what? Solute plus solvent. In that we have learned solute is less in quantity, where solvent is more in quantity generally. Okay.
Yes, ma'am.
Now this solution you have classified into two different parts. One was concentrated.
Ma'am, and dilute.
Yeah. And another one is what? Dilute solution. Okay. Now
Yes, ma'am.
concentrated solution means what? In that your solute is more in quantity. Solute is in more quantity. And in dilute solution, solute is in less
Less
quantity.
quantity.
And vice versa. Means if your solute is in more quantity, your solvent is less as compared to, okay?
Yes, ma'am.
So it will be concentrated. And if it would be the dilute solution, that time your solute would be less in quantity and solvent would be more.
More in quantity.
Fine. And after that, we have again classified this solution in three different parts.
Saturated, unsaturated, and super saturated.
Yes. Saturated, unsaturated,
and super saturated.
and supersaturated. Okay. Now see, saturated solution means what? When
Ma'am,
no more solute can be
is
dissolved
dissolved in solution at given
Yes.
temperature,
at given
it is
temperature.
called saturated.
Yes. When no
Ma'am,
more,
and it will have high temperature, right?
yes. If temperature increases, solubility increases. Keep it in your mind.
Yes,
When
ma'am.
no more solute can be dissolved into the given solution at given temperature is called as saturated solution. And when more solute can be dissolved into given temperature in a solution, that time it is unsaturated solution.
Yes,
And
ma'am.
supersaturated means when the amount of solute present into the solution is more than its saturation level. Okay. When amount of solute present into the solution is more than its saturation level, then it is called as supersaturated
Yes, ma'am.
solution. Clear?
Clear, ma'am.
Everybody understood? Students?
Yes, ma'am.
It is
Yeah,
only
ma'am.
one student is interacting, others are just keeping quiet, and I don't like that.
Yes, ma'am.
Everyone should speak up. Fine. Now see the next what exactly I wanted to explain you about it.
Ma'am,
Concentration of solution. We have learned this, I just wanted to repeat it. Concentration of solution. It is nothing but what?
ma'am, the amount of solute present in the
Present
solvent
into the
at that
given
given
solution.
particular temperature is called concentration of that particular solution.
Yes. Amount of solute present in given solution.
Yes, ma'am.
Why solution? Because solution is a complete 100% quantity, right? Of that
Yes, ma'am.
system. Okay, system means the thing which we are going to observe. So we are going to observe the things which are present into the beaker, right?
Yes,
Yes or no?
ma'am.
So this is our system. Okay. And system has solute plus solvent. That is nothing but what? Solution.
Solution. Yes,
The
ma'am.
amount of solute present in given solution is called
Ma'am, solute.
concentration of solution.
Solution. Yes, ma'am.
Okay.
Yes,
Isn't
ma'am.
it? Fine.
Yes, ma'am.
So this concentration of solution can be calculated by the three formulae. That formula I'm going to give you. That is what? Mass by mass formula. Then mass by volume formula. And another one is what? Volume by volume formula. Okay. In that mass by mass formula, what if both solute and solvent, if their quantities are given in gram, that time you can utilize this formula. If solute amount is given in gram and your solvent amount is given in liter or ml, means volume is given for the solvent, that time you can use mass by volume formula. And both are in liquid state and both volumes are given in ml, that time you can use volume by volume formula. So there is a certain formula which you have to follow. Just the basic information I gave you. So I'll let you know which formula you're supposed to follow for the calculation of concentration. Shall I erase it? I hope you have noted down.
Yes, ma'am.
All of you have to note down running notes. Whatever I'm explaining, running notes should be written by you. that time itself. I'm going to erase it. If anybody is left, let me know so I can wait. Now for mass by mass formula, how you're going to calculate? Mass by mass
Gram
percent.
is solute and solvent are given in gram, right?
Yeah. So when solute and solvent, both quantities are given in gram, that time you can utilize this mass by mass percentage concentration. Okay, which is equal to mass of solute upon mass of solution multiplied by 100. This is your first formula. Why I am going to multiply this by 100? Because we are calculating here what? Percentage concentration.
Yes, ma'am.
The next one, mass by volume. Percentage concentration. I'm writing in a short form. Please write it in a full form. Okay, percentage concentration name you need to write. So you're going to write mass of solute upon volume of solvent multiplied by 100. Okay. And the next one is what?
Volume by volume percentage.
Volume by volume formula. Volume by volume percentage concentration. In that what?
Ma'am, mass of solute by mass of
Volume
volume
of solute upon volume of solvent. Okay.
Yes, ma'am.
Into.
Ma'am, times 100.
Okay. So these three formulae you have to utilize while solving the numericals on the basis of
Okay,
concentration. Apart from that, one more formula is there, what is quite important. I'll let you know. It's very basic. You have learned it in a previous grades. You know about the density?
Yes.
Density is equal to what? Mass upon
Mass by
One.
volume.
volume, right? So
Yes,
sometimes
ma'am.
what happened? Quantity may it given into the volume. They may give you density. They may ask you to calculate mass by mass percentage. If quantity is given in a volume and density is given, so you can convert the volume into mass by using this formula, right? Density is equal to
Right,
mass
ma'am.
upon volume. So how you can convert it into the mass? Mass is equal to volume into,
Volume
as
into
volume is here divided, it goes there, it become multiply, right?
Yes, ma'am.
It will be volume into density,
Density.
correct?
Yes, ma'am.
Yeah. Clear?
Clear, ma'am.
Fine.
Yes.
So means you can convert it and you can utilize it. If mass is given, you can convert it into volume. If volume is given, you can convert it into mass. And
Yes,
according to requirement or asked, whatever asked in your problem, whether they asked you to calculate mass by mass percentage or volume by volume percentage, according to that, you can revolve your formula and you can write it down
Yes,
or
ma'am.
find the solution for your problem. Clear?
Clear, ma'am.
Yeah. So I hope all of you wrote down this.
Yes, ma'am, we did.
Yeah. Shall I erase?
Yes, ma'am.
So one problem is there. Shall we solve that problem now? One numerical.
Okay.
Fine. So it's solved example in your book, but then many of you are not able to solve by looking at that directly as well. So you should be aware what means, like the methodology, what you're supposed to follow exactly. Sometimes temperature conditions are also given. One is a salt, another is an unsolved in your book itself. Do not think about the temperature. That temperature condition is given for the saturity of the solution. Because just now we have defined the saturation or a saturated solution, means like no more solute can be dissolved in the given solution at that temperature. So temperature condition is given for telling us like that solution is a saturated at that particular temperature. Understanding? So do not think much about that temperature, because what happened, what I have observed in my previous classes, is wherever I have taught, whenever something different thing would be asked, student gets stuck over there and they feel like that this is something new and it's not been taught. Okay, it's not like that. Just think whether it's related to your problem or not. If it is related, then only utilize. If it is not, kindly ignore. Okay. Yes.
Okay, ma'am.
Fine. So the problem is what? Write down. A solution contains a solution contains 40 grams of common salt, in 320 gram of water. Correct? Calculate the concentration in terms of mass by mass percentage. Of solution. Now in this problem, temperature is not given because it's not required. Sometime it is required, that time they will give, but then that would be given only for the sense like the solution is saturated. But then here they didn't give you like the term like saturated solution, isn't it? So what is given in this problem? Just take a look of it. What
Ma'am,
happened?
solute and solution.
Many of the students left or what? Only 5 students are there now.
Ma'am, solute and solution?
Sorry.
Ma'am, 40 grams will be the solute and 320 will be the solution.
Yeah. So what you're going to write here?
So ma'am, for mass by mass percentage of concentration is?
You write down amount of solute.
Yes, ma'am.
Amount of solute is equal to how much? 40 grams.
Yes,
Right?
ma'am.
Then amount of solvent.
Ma'am, 320 grams.
Yeah. That is water, 320 grams. But then solution is not given to you, but in your formula, you have to use the solution, right?
Yes.
Yes, ma'am.
Yeah. So
We
amount of
add
solution
40
is
plus
equal to
320.
Yes,
Yeah.
ma'am.
Solution is equal to solute plus solvent.
Solvent.
That is equal to what? 40
Ma'am,
piece.
it will be 360
Yeah, that will be
grams.
360 gram because both quantities are in grams, so need not to convert anything in any volume or volume need not to convert into grams, right?
Yes.
Yes,
So
ma'am.
that density is equal to mass upon volume. That formula need not to use. So you have a formula, mass by mass percentage,
Yes, ma'am.
percentage concentration, that is equal to mass of solute,
By mass of solution.
mass of solution. Don't get confused. Most of the students write it here mass of solvent.
Yes,
So
ma'am.
that should not be happen, okay? Into 100. So you just put the values in this problem. Mass of solute is 40. Okay, mass of solution is 360. This by the addition of both multiplied by 100. Correct?
Yes,
This
ma'am.
this zero get cancelled.
Ma'am, it will
4
be
ones are 4.
25.
Yeah, 4 ones are 4, 4 nines are 36. That will be equal to 100 upon 9. And when you divide it, you will get 11.11 kind of, right, percentage. Is it like that?
Yes, ma'am.
Yeah.
Yes.
So this is what mass by mass percentage of your solution.
Yes,
One
ma'am.
more question is there, which you need to solve in a same manner. But then in that problem, so this is given to you. Temperature condition is given to you. Do not think much about that temperature condition that is given for showing that it's a saturated solution at that particular temperature. You need not to use that anywhere. Fine.
Yes, ma'am.
I will post it in your homework, that problem. Is it okay?
Okay. Yes, ma'am.
Fine. Whatever I taught, all of you understood clearly.
Yes, ma'am.
Yes.
Yeah, because what I feel like that by 6 o'clock, till 6 o'clock, 8 students were there and 3 students left
Yes, ma'am.
since last 4 to 5 minutes. Why this is so, I
Yeah.
don't know. I'll speak
Ma'am,
with them
because
better.
we have one more class after this one, around 6:10.
Acha, immediately after 10 minutes. Okay, fine.
Yes, ma'am.
So I'll end the class now. Okay.
Yes, ma'am.
Take care, students. Bye.
Thank you, ma'am.
Bye.